students, one more very important topic for this chapter is the mass and weight. Yes, I know lots of you people consider these two things that they are equal, like there is no change of the mass and the weight. And when we are taking the examples of ball or any body that is falling on the earth, you might have thinking that this mass is actually the weight of the body. Okay, that is different thing. Okay, so here, because we are talking about the gravity, why I am taking this topic in this chapter is because mass and weight are totally different things, and that too depend on the gravitational force. Yes, so here we are having the difference between them, that the mass and the weight. First point is the mass is quantity of matter contained in a body. Like the body, any body, if we talk about any football, let's suppose, now this football is constituent of the rubber and the water and the air molecules that is present inside in the form of gas. Okay, so these molecules on the surface that has been made of rubber, and inside this the amount of the molecules, amount of particles, or I can say that consist here. Okay, that is making this whole body. So that quantity of matter, कितना quantity है, okay, ये mass होता है, that is its own. ये नहीं होगा, that is not applicable, that is not depend on any other celestial body or any other external body. But in case of weight, now this weight is nothing but a force. Okay, so whenever you think about weight, consider this is a value of force. Okay, now when we are going to some shop and weight ourselves, we are actually measuring the value of force that the earth is pulling us towards itself. Okay, so here weight, what is it? It is a force by which a body is attracted towards the center of the earth. Now this football again, because the amount of the particle is considered here, these all particles constituent and making its body, and that particles, if we are adding up all these things, that will wholly making a mass of the body. Okay, now, but in case of weight, the weight of this body would be different. Okay, now it depends by how much force the earth is pulling it towards itself. The force value, that is equals to weight. Okay, so this is the first thing that you need to know, and this, I think, made you clarify that the mass is the individual thing of any object, but weight depends on which planet it is actually situated. Okay, but because of the planet, it is get pulled by the planet. Okay, if like this football again is on Jupiter. Okay, so the weight if you are taking there would be different, that is from the earth. Okay, Jupiter पे इसका weight अलग आएगा, earth पे different है. Fine. So the second thing here is the SI unit of the mass is kg, and because this weight is nothing but a force, and we know that we calculate the force in form of Newton, so the SI unit of weight is Newton. I think ये भी आपको पता नहीं होगा. Fine. So now the third thing here, the mass remains constant. Okay, ये almost like this rubber ball. If you are taking this on the space and into the another celestial body or in any other galaxy, the amount that is constituted inside it would be remain same. Okay, so we can say that the mass would remain same wherever you are taking this ball. But the weight of an object changes as per the acceleration due to gravity, because the gravity of different planet would be different, because the pulling of it would be different, and that too depends on the mass of itself. Like the earth is having a mass 1, and Jupiter, because it is too big, it is having a mass 2. So because of its large mass, it is having a large gravity. and because it is having a less mass, it is having a less gravity, that is 9.8 meter per second square. We have read that. Okay, but in this case, because it is very big out of this shape, like in Jupiter, these Earth, अगर हमें Earth को यहाँ पे submit करना है, then we can put 1300 Earths here in the Jupiter. Okay, तो इतनी सारी Earths इसके अंदर आ सकती है. So the gravity would also be affected, and that gravity depends on the mass of it, and that would be too high, and the wall there would be considered because the pull here would be more. Okay, so the pull, like अगर मैं एक और example से समझाऊँ आपको, so have you heard about the spring balance? जो spring balance है, we are having a hook here, and let's suppose we have applied here, we have like hold here a toy, any toy which has certain weight. Okay, so according to that we have put here, so उसके according यहाँ पे कुछ value show होगा. Fine, and when a kid is coming and it is pulling it toward itself, it has been pulled it. So now the value that has been shown by this spring balance would be greater because it has now been pulled. In the same manner, because we are having certain individual masses, but because we are getting pulled by the planets, that is why now we are having different weights. Okay, so more the pull, more the weight, less the pull, less the weight. Some more differences of the mass and the weight are here, that the mass of the body is same on Earth and Moon, that I have told you. Wherever you are taking that rubber ball into the space or into the galaxy or in any other celestial object, so the mass would never get affected because the constituent atoms would be the same, and that makes the mass of that. Okay, and the weight of the body on the Moon would be the 1/6 of the mass of the Earth, because the mass of the that is Moon. So according to that, the pull of the Moon would also get affected, and there you will feel lighter because the Earth here is pulling us with a great force. Like suppose if I am weighing here 30 kg, okay, so now on Earth, okay, so now when I go to Moon, now it will become 30/6, that is 1/6 of the weight that you are having on the Earth planet. Then there I will just wait for the 5 kg. Oh, I will feel very lighter. Okay, so this is what the mass of any celestial body plays an important role about the pulling. Okay, this Moon, now you are considering that, ma'am, the Earth and Moon are not of that like इतना भी फर्क नहीं है उनकी साइज में, then इतना ज़्यादा वेट में कैसे फर्क है? Because the Earth is filled with, till core, it is filled with certain masses, but Moon is considered that it is hollow, little part of it is a hollow from the inside. That is why it is very lighter, and it is applying a very less gravity on the objects. Now the fifth thing here, as you can see, mass of the body can never be zero. Okay, in case of mass, if any object exists, like this marker exists, any ball exists, any apple exists, that has been made with certain atoms and molecules, and that atoms and molecules together is forming that has contained certain mass of itself, and that is gives the idea of the mass. That is why if anything exists and it is available, then we can say it is having a mass. Okay, and that mass could not be zero. If anything is zero, then we can say it does not exist. Okay, but in case of weight, if the gravity is zero, then the weight is zero. Like if I make you to into the space, like if I tell you to go into the space and randomly, like into the vacant space, not on any other planet, fine, so there you will weigh zero because you are not under the influence of any gravity. There is no gravity like outside the Earth into the random space anywhere. Here no body is there which is affecting you. You are just having your own mass in this case, but the weight will become zero because no object, no other celestial body is here which is pulling you towards itself. Now the sixth point here is the mass is a scalar quantity. It only has a magnitude. Okay, but the weight is a vector quantity. It has magnitude as well as the direction. Mass is a scalar quantity because it does not need any direction. It is constituent into itself and complete into itself. That is why any object is having the molecules and objects that is filled inside it, contained by it, is considering as the mass of that object. Okay, so it doesn't mean that where the pulling or pushing is applicable. Here, not a case of that. But in case of weight, you know that it is being pulled into the direction. Okay, so whenever it is get pulled, so now we can say that the part of the direction is working and the direction is considered as the vector quantity. So we can say that the weight is a vector quantity and the mass is a scalar quantity.